Everyone, and welcome for a lecture 14. Today, I want to cover about assert and classes. I'm gonna try to have the this session, this semester wrapped up with classes. Hopefully, this is gonna be the last major topic of the session. So most of it after this is gonna be about classes. So nonetheless, anyways, assert. So in C++, we usually make assumptions in the program, like an array index should be greater than 0, etc., or whatever assumptions that you might come to mind. When these assumptions are true, the program runs fine, but when these assumptions are false, the program it doesn't end normally, like that return 0 that you have at the end of the main function, but in this example, you'll see it ends with a core dump. Okay? Um, Typically, an assert is a statement in C++ which is going to test for a condition. If the condition is true, the program continues normally. If it's not, then the program terminates abnormally. And the way you go about using assert is you have the C assert library that's used. Let me jump right into the example so they'll make it clear for you. Um, Here is a normal example. Don't pay attention to define no debug right now. I'll come to it in a little bit. So here, in this case, just for simplicity's sake, for keeping it very simple, I said assert and I used two expressions there, 2 plus 2 and, does it equal 3 plus 1? It doesn't have to be this, right? I talked about the index of the array. Anything you want to check, you'll use assert for it. Okay, so here I have assert and then I give it a condition, right? So typically you'll have a condition in the parentheses. 2 plus 2, does that equal 3 plus 1? If it's true, then expression is valid and the execution continues. Um, and then the second assert that I have is 2 plus 2 equals 1 plus 1. Um, that is, like, assert disabled, execution continues with that invalid expression. Let me try to run this and show you what happens, and then I'll explain. See? Program finished with the exit code 0. It did continue. Expression's valid, but the second a.out main.cpp in line 10, it said the assertion failed. Okay? So the program ended abnormally. What you want to do is, so this is there's also this concept of the debug version of an executable and a release version of the executable. Typically, when you release something out to the field, there is a debug and a release version. Release version doesn't have all the output statement, the login, and all of that. Typically, when you run into a problem, you run the debug version of your code to find out where the problem's at. So here, the way to run it in debug is, let's do this. Now, notice a difference here. Execution continues with invalid expression, whereas before the program failed. Now, what happened was in normal circumstance, the program would have exited abnormally, but in this case, when it's the debug version, the program did not exit, but the execution continued on. Now, the reason why this debug version will help you is, there's a problem, but you want to move ahead from that problem and see what else is going on in the program. So that's why you run the debug version, and in this case, the program just continues on. Um, what else about assert? Like I said, you can use it for any condition that you like. Um, uh, and assert is a preprocessor macro that's used to evaluate a conditional expression. So it's a macro that's provided for you. If the conditional expression evaluates to false, then the program is terminated after displaying the error message. The error message typically contains the failed condition expression, name of the code, and the line. In the first example, that's exactly what you saw. And see in this case, line 10, that's where the problem was. Okay, I ran the release version. Okay, so that's what I wanted to cover for assert. Next, moving on to the big topic, classes. Before I tell you what classes are all about, whenever we talk about classes, this concept comes about object-oriented programming. Now, there is object-oriented programming and procedural programming. Procedural programming, that's about writing procedures or functions that perform the duties that you want from your code. Whereas, um, object-oriented programming is completely different. It's based on the concept of objects and classes. So you have the work done by different objects and classes. So it's completely different than the functional programming. In your functional program, you can have one long file that does everything or break it up into methods. Whereas in object-oriented programming, you'll have classes and then you'll have object. Now, what's a class? A class is a user-defined data type which has data members and member functions. Once you see an example, it'll make sense. And what's an object? An object, it's an instance of a class. Think of it this way. When you say int I, right? I is the object of type int, and the same thing goes for classes. And data members are the data variables, and member functions are the functions used to manipulate these variables. And together, these data members and member functions define the properties and behavior of the objects in the class. Woof, that was a long sentence, right? So let me try to break it down for you. So, uh, in a class, let's say, for example, you've got people always use this. I'll continue to use it. Think of a class which is car, okay? You have a base car. Car has tires and a body and a steering and an odometer. All cars have this, okay? So the its data members are tires, body, steering wheel, and odometer. And what are member functions of this class car? The member functions would be the ones that would let you change, update, or retrieve the body, the steering wheel, and the odometer. Okay? So you've got a class. It's got data members, and in order to play around with those data members or find out what the data members are, you're going to call member functions. And towards the end of the class, if I have time, the last thing I want to cover is the accessors and mutators, which essentially are these member functions that are designed to give you the flexibility to change, update the data members of the class. Okay, let me show you an oh, actually, you know what? Let me cover this as well. Excuse me. So the way we go about defining a class is you have the keyword class, and then you give it a name. You can give it any name you want. Open parentheses, close parentheses, colon after that. And in it, you have these data members, an integer, a string, a character, whatever. And then you have these member functions. And we're going to get into mutators and accessors in a little bit. But the member functions are nothing more than just methods that are provided to you to play around with the data members of the class. So that's how the classes define. Okay, you with me so far? Let's jump into an example. You are familiar with this. include IOStream using namespace std. I have a class called geeks, um, opening parentheses, closing parentheses. So everything that's in this is uh, under class geeks. So there is public, private, and protected. So if you have, once I go into protected and private, I'll tell you what those are. But if you have the keyword public, such as I do over here, anything below it till the end of the class in this case, it's all public, meaning anybody can access it. It's open to the entire world. And the data member is the geek name, it's string, and the member function is print name. So print name, all it's going to do is tell you what the geek name is. So that's a class. And what's an object? Geeks object one. So that's an object of type geeks. Accessing data member. So the way you go about doing it is you name the object, whatever name you chose it, that dot the name on the member function. obj1 dot geek name. And what I'm going to do uh, is set the geek name to ABHI. And then I'm going to print it, right? Because this is going to tell you what the printed name is. See? Geek name is ABHI. So in here I was able to declare a class, have an object for that type of class, set its name, and then I'll put its name. Okay? Sounds pretty straightforward, but um, people who are working with classes in the beginning tend to run into all sorts of issues. Um, so the example might seem very simple, like, oh, what's the big deal? Well, it is going to be a big deal once you actually start, uh, working and looking into classes. Now look at this slight variation of geeks. I have a geek name and then I have an ID. And I say print name, um, and then I have print ID. And all it does is geek ID, so on and so forth. But in this, what I have done is I've taken the implementation out of print name from the class, and it's outside. It's outside over here. Definition of print name using scope resolution operator. So the way you go about doing that is you have, so instead of having void, so the name of the method was print name. Instead of having void and print name, you have the name of the class, and this is called the scope resolution operator. Right, these four dots right here. And that's the way you go about implementing a function outside the class. And if you've thought about this already, or you probably are, um, you can easily have the implementation of the methods in a completely separate file, right? So you have your .h, your geeks.h, geeks.cpp, and then your main driver that deals with geeks, right? You get the point. So in here, I have an object of type geeks, and I set the geek name and set the ID. And then I print name, and I call print ID and see what happens here. Geek name is X, Y, and Z. That's what you set it. And ID, I set it to 15. That's where it's still at, right? Okay. All right. So let me go on and try to jump into accessors and mutators since we're doing good on time. Um, Before I go into that, now I did kind of mention the public method of the class and public data members. And then there's private and protected. You start using private and protected. Think of it this way. I'm trying to illustrate to you the reason why you'd want to do that. Let's say, for example, there's a bank teller class, uh, and the bank teller has money with him or her. Not everyone in the entire world can know what or how much the money is with her for safety reasons. Even though I'm a loyal customer, I cannot have it. So that method to retrieve uh, the amount or to update the amount is going to be private because you don't want it open to the whole wide world. Okay. Now, the next concept is the accessors and mutators. In here, I have a class called, don't mind the compiler. You know, I tend to use all these online compilers. Um, I mean, I could have used VI or, log into PuTTY, etc. But let's just go with what I have. So in here, I've got a class person, and then I've got its members, data members, first name and last name, and date of birth. Now, one of the methods that I have here, it's still public, get first name. I'm not going to use this operator. Once we get into pointers, you'll know what this is, the keyword this, and you'll get very familiar with it. Okay, get first name. All it does is return the first name. And then I have a void set first name that takes in the string and sets the first name to whatever that string was passed in. Now, um, this method right here is going to be called the accessor because I'm trying to access the first name. And then this method right here is going to be called a mutator. So all your sets, all the methods that manipulate, update the data members are called as mutators because they literally mutate the fields of the class. And the accessors are the ones that just return the data members. Okay? Now, now let's go down into the uh, main method. So I have a person A. So the class itself is a person class. I have person A dot set first name to Alex. Run it. No match for call. Shouldn't there is no method. That's the mistake I made. Sorry. Right, no problems. Now I am going to say C out. Okay, I'm setting the first name and then I'm retrieving it. That's set first name is the accessor. Um, get first name is the accessor. Set first name is a mutator. See, the first name of person A is Alex. Okay, since we're doing good on time, I wanted to cover something else. Constructors for classes. Um, going back to the person class, if you don't, I didn't really give it a constructor. Let me show you here what I'm talking about. See this? There is no constructor here. Um, so when I did this statement right here, person a default constructor got created, or I should say it was actually created. Anytime you don't have a constructor, the compiler is going to provide you with a default constructor. Um, and you can have a constructor, in this case, takes in the string first name and the string last name. See what I did was I commented out the date of birth. just for sake of simplicity, because I'm only going to be using this uh, to illustrate the examples. So first and last name are the two data members. In this case, you could have a constructor that takes in the first name and the last name, and then you set it appropriately. The other thing is the copy constructor. If you don't provide one, a default copy constructor is going to be provided to you by the compiler. Let me show this how it works. Um, in this case, I'm sorry. When I first did this, when I showed you the example in the first time, I don't really have a constructor. Whereas now I have a constructor here. Watch what happens. Let's say test, test. Let me run this again. What happens? The name of the person A is test, right? When I called A, what I did was I set the name to test, right? So the constructor is getting called. Now the other thing I can do is I could say person that takes in string, first name, and string, last name, and do this, and then say first name equal to first name. Lots of typos here. Last name equal to. Now, if I were to do this, forget about setting the first name right now. Person A, I call him, what do you want to call it? Jason Rock. Just made up a name. Mm, line 23, first name. Oh, I misspelled this last name. See here, I can have another void. Let's have this. Something that an accessor for the last name. String get last name. Return this. Not very legible right here, so let's go ahead and make it more clear. So, but you get the point. So I've got an accessor for last name as well. So in this case, I set it to Jason Rock. First name should be Jason. Last name should be Rock. The last name of person A is A get, right? First name is Jason, last name is Rock. I can have another constructor in here that takes in what do you think is going to happen in this case? I only gave I'm calling the constructor that takes in the first name, but I'm not setting the last name to anything. What do you think is going to happen? Right? The default did not constructor did not get called because I specifically called a constructor that only takes in the first name. Since the last name wasn't set to anything, it's blank. Okay. Um, what else? Copy constructor. Like I said, typically it's provided for you, but it's a good practice to have a copy constructor of your own. Um, so I'll have person that takes in const person b. So what I'm going to do is first name equal b dot get first name, right? And last name equal to b. So that's how you go about having a copy constructor. Like I said, if you haven't defined it, the compiler is going to make one up for you. But it's always a good practice to have a default copy constructor.